In 1938, when the hero of my previous video, the F4 Wildcat, had only just gotten onto its wings, the WMA in the USA was already concerned with the problem of its future replacement. A new contract was signed by the firm Chancewood, which proposed a fighter project with an unusually curved wing in the inverted gull configuration. The F4U Corsair was distinguished by significant technical novelty, and therefore the refinement process dragged on badly. By the end of 1940, it became finally clear that Chance vowed would not manage to meet the deadline. Then the head of the competing aircraft building corporation, Grumman Engineering, Leroy Grumman, proposed to the fleet, as a temporary measure, to adapt his already mass-produced F4 Wildcat to a more powerful 1,600 horsepower engine. Someone will call it a timely and sensible proposal. Or is it not so simple after all? It is hardly likely that the sly Fox Grumman could have failed to understand that the selected replacement power plant, a 14-cylinder twin-row Wright Cyclone weighing almost 900 kilograms, would never fit onto the old airframe of the Wildcat, especially considering that at that very time Grumman Engineering was actively developing the Avenger torpedo bomber, equipped with that very engine. But at that moment, of course, the main thing was that the fundamental agreement to begin work had nonetheless been obtained. Thus was born the fighter project under the index G510. Despite the fact that the terms of reference spoke only of modernizing the Wildcat, the teams led by the talented engineer William Schwendler in the shortest time designed an entirely new machine. One can say that from its predecessor, the XF6 inherited only the general lines of the fuselage. Everything else was new. The fighter changed from a mid-wing to a low wing. The landing gear underwent a fundamental redesign. To the delight of all naval pilots, it finally acquired a hydraulic drive. The track increased significantly. The greater strut height now made it possible to install a highly efficient 4-meter variable pitch propeller. On January 12, 1941, the full-size mock-up was presented to the Bureau of Aeronautics Commission. After a long and difficult meeting, the largest carrier-based fighter of its time was approved. A month after the United States entered the Second World War, the fleet ordered 1,000 Hellcats from Grumman. Exactly 6 months were allotted to fulfill the assignment. Quite optimistic, considering that by that time not a single flying example yet existed. The work proceeded at an accelerated pace. Finally, on June 26, 1942, the prototype fighter took to the sky. The joy of this event was soon dispelled by the results of the subsequent tests. It turned out that the engine reserved for the machine did not allow the required specification characteristics to be achieved. According to measurements, the new aeroplane in many parameters only matched the level of the Wildcat, but Leroy Grumman did not even think of giving up. By pressing where needed, he managed to secure for the machine the most powerful of the serial aircraft engines being built in the USA. The 46-liter twin-row Pratt & Whitney R2800 went onto the engine mount of the second prototype as if flying in, which is not surprising, since such a replacement had been prudently envisaged by the engineers from the outset. Thus the Hellcat acquired its finished form. The serial F6F did not lose the main virtues of its predecessor, high reliability and structural strength. The machine could still boast excellent survivability. The main vulnerable areas were covered with armor. The cockpit was especially well protected. Steel plates were placed in front, behind, and under the feet of the American pilot. All fuel tanks with a total capacity of 950 liters received self-sealing. A takeoff weight of 5.5 tons for a piston engine carrier fighter did not become an obstacle. The 2,100 horsepower engine at 6,000 meters above the ground confidently accelerated the not small airplane to 620 kilometers per hour. The other characteristics increased substantially as well. You can see them on the screen now. The biggest revelation for the fleet pilots who had moved into the spacious cockpits of the brand new fighters was that the massive aircraft had significantly gained in horizontal maneuverability. The large weight also had an unexpectedly positive effect on landing qualities. At low speeds, the aeroplane was less susceptible to crosswinds. Orientation in the air and on the tight deck of an aircraft carrier was aided by another very interesting decision. The propeller axis and the Hellcat's tail unit were shifted relative to the horizon by 3 degrees downward. Thus, the highest point of the fuselage became the pilot's cockpit. In general, as is not hard to guess, the Hellcat suited the flight squadron's taste. It was time to test it in combat. A full-fledged debut can be considered the raid of 6 aircraft carriers on the airfield of the Japanese-occupied island of Wake. In the pre-dawn haze of October 5, 1943, half a hundred Hellcats rose from the decks of American ships. On approach to Kotolu, they were intercepted by 27 Japanese A6M30 fighters. In that battle, the Americans lost 6 of their machines while destroying 22 enemy aircraft. Having a speed advantage of about 70 kilometers per hour, the Hellcat allowed the American pilot alone to decide the start and end of any aerial engagement. The opponent's climb rate up to the mark of 4,000 meters was roughly comparable, but above that, the much more powerful engine of the Hellcat gave a noticeable advantage. A favorite tactic of a U.S. pilot was vertical fighting. On sighting the enemy, Hellcats at full power would quickly gain altitude, then begin to dive and turn on the opponent stuck below. Having made a pass, the pilot, without getting involved in a knowingly losing turning fight, would once again shoot straight up. Such swings were sometimes limited only by the supply of fuel or the ammunition load. The enormous weight accelerated the machine excellently in a descent, but here the pilot had to remember that exceeding the 850 km/h speed threshold threatened his fighter with serious damage. On November 5, 1943, the aircraft carriers Saratoga and Princeton launched all their aircraft to strike the vital naval base of Rabaul. The forces were roughly equal. 52 Hellcats and 45 bombers and torpedo bombers were opposed by 6 dozen Zeros. Constrained by the necessity of strictly following the strike aircraft, the Hellcats acted more tightly this time. And nevertheless, the result of the battle says a lot. For 5 downed F6F, there were 12 of what had recently been the world's best Japanese carrier-borne interceptors. How much of an advantage the Hellcat gave in the aerial carousel over the Pacific is eloquently testified by one fact. On November 23, 12 American fighters clashed with 21 Zeros. In the brief battle, all the Japanese aircraft were shot down. Moreover, 5 of them were credited to Second Lieutenant Ralph Henke, for whom this fight was his first combat sortie. In subsequent engagements, the F6F only strengthened its renown as the strongest naval fighter. Its finest hour is rightly considered the battle that unfolded on June 19, 1944 in the Philippine Sea. Then the Japanese threw all the carrier aviation forces they still had left at that time against the American fleet preparing to land on the Mariana Islands. In the sky, 324 Japanese fighters and bombers met 443 Hellcats. At the cost of losing 22 of their own aircraft, the Americans destroyed 217 enemy machines. Thus, in just one June day, the carrier aviation of the land of the rising sun, as a force to be reckoned with, ceased to exist. Of course, besides the Zero, Japan also had land-based fighters, and with some of them, the Hellcat really did have problems. The widely known example is Japanese ace Tetsuza Iwamoto, who, flying the Kawanishi N1K1J interceptor, single-handedly engaged a 6-ship group of Hellcats and managed to destroy 4 of them. The Shiden, as well as the Mitsubishi J2M, the T-84, and the Kai-100 were formidable opponents, significantly surpassing the Hellcats in speed and climb at low altitudes. But to compare carrier and Army aviation head-on is not quite correct. After all, the requirements imposed on the equipment are initially far too different. Besides, there were still far too few new Japanese fighters to exert any noticeable influence on the course of the concluding period of the war. Hellcats also fought in Europe. Their long range made them the aircraft of choice for covering British bombers in their raids on the well-protected berths of German ships and submarines in the fjords of northern Norway and along the western coast of France. Here, the Cats more than once had to engage with Messerschmitts and Focke-Wulfs. The Hawks of the Luftwaffe, having better acceleration characteristics, readily accepted combat in the vertical. Losses grew. Fortunately, soon enough, Mustangs entered the armament of the escort forces in sufficient numbers, and the use of the Hellcat as an escort fighter was abandoned without regret. In all, within Lend-Lease, 1,200 Hellcats were delivered to Britain. Not a small number, true, and yet that was only 1/10 of the total number of fighters produced at the factory on Long Island. Simplicity and manufacturability, together with effective organizational decisions, made it possible in a short time to set up truly mass production. By mid-44, a paradoxical situation had taken shape. Grumman was shipping more Hellcats than the U.S. Navy needed. As a result, the military had to ask the aircraft manufacturer to curb its ardor, limiting output to 600 aircraft per month. By this time, the need for modernization had matured. First of all, the engine was refined, receiving a water injection system. Armor protection was strengthened, and at the same time, the tail section, often deformed on landing, was reinforced. Under the wing of the F6F appeared pylons for suspending bomb and rocket armament. Now the Hellcat almost always went on a mission with a pair of 450-kilogram aerial bombs or 6 unguided rockets. In principle, even a torpedo could be slung under the fuselage, but for fairness, I have not encountered evidence of the use of such a weapon. The updated aeroplane made its mass debut in the skies of the Philippines, where it clearly demonstrated its advantage. By the results of the combats, for one cat shot down there were 19 Japanese aircraft. It reached the paradoxical, sometimes ignoring orders, pilots entering an aerial duel, deliberately did not jettison the aerial bombs hung under the wings. But war has more than once shown that it does not tolerate a contemptuous attitude toward the enemy. Thus, in the raid on Formosa, American pilots became so carried away with strafing the Matsuyama airfield that they lost sight of 24 old-timer Zeros loitering under the lower edge of the clouds. Lacking an altitude advantage, all 12 American aircraft received one or another kind of damage. 4 Hellcats were lost. Some F6F left the production line in the night fighter modification. The armament of these fighters was different. Instead of the standard 6 heavy machine guns in the wing, they carried only 4, supplemented by a pair of 20mm aircraft cannons. Under the right wing in a fairing was a radar. In the tail, an identification friend or foe device. On the instrument panel of the night fighters, a radar display was mounted, allowing a single aerial target to be detected at a range of up to 9 kilometers. On closing, the pilot switched the instrument to radar gunsight modes and then, orienting himself by the position and range marks of the enemy machine, opened fire from a distance of 300 meters. The night fighters did not gain wide fame since by the moment of their appearance, the Japanese air forces practically did not have crews prepared for night attacks. And yet, the time of the rough, overweight aircraft made to please manufacturability and cheapness of production was drawing to a close. In the hangars of American aircraft carriers, the Hellcat was yielding place to the faster Corsair. In 1951, the veteran officially retired. With the start of the Korean conflict, a small part of the F-6 were taken out of storage and used to destroy especially important targets as remotely controlled aircraft missiles. And in a whole number of Latin American states, these docile machines, which easily forgave gross piloting errors, remained on guard of the sky right up to the early 1960s. In the Second World War, the participating countries employed dozens of different types of fighters, but only a few managed to pass this difficult path as brightly and flawlessly as did the Hellcat of the Grumman firm. The Hellcats account for 75% of all aerial victories won by American aviators over the Pacific Ocean. 306 pilots flying this type of airplane were awarded the high title of Ace. By the end of the world conflict, the Hellcat had become a more universal machine, trying on the roles of reconnaissance aircraft, bomber, night fighter, anti-submarine aircraft, attack aircraft. Its high thrust-to-weight ratio, payload capacity, incredible structural strength, and survivability made all this possible. And all the same, the big aeroplane will forever remain in my memory as simply a fighter, the best carrier-based fighter of that terrible war. Thank you for watching, peace to everyone, and we will hear from each other again very soon.